number 21, merge two sorted lists. This one I am doing it differently simply because I have attempted it for 20 minutes and due to my simple lack of reps, I didn't know how to go about it whatsoever and I was kind of stuck and there was no productive footage even to show anything. I was lucky enough to have a classmate teach me and walk me through this problem. And so, what I'm going to try to do is explain to the best of my ability what I've learned, how I think this problem is supposed to be solved. Problem is, you are given the heads of the two sorted. Basically, we're just merging two linked lists into one merged linked lists, and we're just returning the head. This reminded me of the sorting algorithm that we learned recently. So what you would do is compare the first elements of both sides, and then whichever is smaller you put in first, and then you increment it, and then you compare that incremented value with the other one. In this case they are the same, so it doesn't matter. But let's say we started here, 2 and 3. Put 2 first, and then increment 4 to 4, because 3 was bigger, and then we compare the 4 with the 3, etc. So I had that sort of like logic in mind, but when it came to linked list, I was like stuck. My friend kind of walked me through it. So I'm gonna kind of go over the answer key right here. Method signature was given to us. So we have the function name merge to list with two linked lists as a parameter, and we gotta return the list node. So at the end, we are returning a list node. The first thing we did was to create a dummy node. This was basically equivalent to creating a third linked list. The way linked lists work, from my understanding so far, is that unlike, let's say, arrays where name them, let's say, right, and nums would be the name of it, versus in linked lists, the only thing we're saving is the head. So kind of if we were to look at like arrays where the memory is contiguous, and then this would be like 0th index, 1, 2, 3, 4, 5, and they're like continuous, versus linked lists where these pieces of what they call nodes are floating around, and all they're doing is just like pointing to different nodes. And the only way they kind of keep track of who's in this is by keeping track of the head. In our case, we named it dummy, and then we assigned it a list node current equivalent to temp. We're currently pointing to the dummy node, like the head node. So we have the dummy node right here, and we're pointing it to the dummy node. And the next thing we're doing is we made a while loop with a condition where we are not at the end of list 1 and not at the end of list 2. So making sure that we traverse through both list 1 and list 2 in this loop. And within this loop, what we do is we simply compare the value of list 1 and list 2. So here what we would be looking at is, if we were to use example 1 here, list1.val, so comparing the very first value of list 1 with list 2's value, and whichever is smaller of the two would get placed. But if they're the same, then we would just follow this logic. So list 1 is not smaller because they're equivalent, and that is why list 2, the purple nodes, will be pointed to. So current.next is pointing, so the dummy is pointing to list 2, and the line here where it says list 2 is now equal to list 2.next. So to understand, and because we have used this guy, we needed a way to increment this basically, since if we didn't, then we would only be comparing the head value forever, which is not what we wanted. And the way we increment it is by doing this. List 2 now is pointing to list 2's next value. So because we use this, now we are moving on to this value. So we are now pointing to 3. And this line is also important. Current, which is, so we had the dummy, so current, and we have filled in the first head with 1 from L2. Now, we if we didn't move the pointer, all we would be doing is kind of repeating, overriding whatever is in the head node, and therefore we needed to increment that as well. And the way we did that was by doing this. Now the current is pointing to the current dot next. So instead of here, we would be pointing now at this location. And then we kind of go back up since we're looping it before we exit that. Now we repeat the process. So now we're still comparing list 1's value and now with this value. And obviously 1 is smaller, so 1 joins here. So clearly I don't understand why the last 4's are like this, because I feel like it should be swapped. But that's kind of the general idea. And then because they are both at the end and we can't change it, that's when we are like, okay, we're done, and return it. So that's the general idea. Maybe I'll confirm with Claude to double check. Ready. So Claude is saying that the diagram is wrong and it should be flipped. Just making sure that I'm understanding the code correctly. Finally, these two if statements would check in case either of them had longer or shorter lengths. Just continue traversing to the other node until you see the end. And we give them dummy.next because that is going to point to the very first head that we see here, which is what they asked for. So today was the first time where I kind of stopped simply because I didn't know what to do with the concept. I feel like with arrays and the previous questions, there was at least like room to think what I should be trying versus with the linked lists, while I thought I understood the concept in class, without not grasping the whole syntax and how linked lists work, made it difficult to even start. So I want to give a big shout out to my friend who taught me. I'm not going to name him because I didn't ask for his permission. He really helped me understand it properly, I think. I think it was a good, appropriate challenge to get my feet wet on something other than array for the first time. And also, utilizing the whiteboarding on this website was pretty nice. I feel more comfortable with linked list, and hopefully that will come in handy as we get into a more sophisticated data structure that is not arrays. Definitely a lot learned today. Thanks for watching. Till next time.